Welcome to our lesson on midsegments. Today's objective, we will know how to apply the midsegment theorem to triangles when we're finding the lengths, slopes, and/or solving for a variable. So the midsegment theorem says a midsegment connects the midpoints of two sides of a triangle. So if I take any two midpoints, so any two sides, and find the midpoint, I can connect those to create a midsegment. This midsegment is going to be parallel to the third side, the one that it's not connecting. And that same third side is going to be twice the length of that midsegment. Every triangle has 3 midsegments, just to make note of that. So let's talk about parallels. So in this first example, DE is parallel to which segment? So DE is a midsegment. So that means we need to find the side that it's not connecting. So if I look at this, DE is connecting this top side and the bottom right, which means DE will be parallel to AC, that bottom left side. AB. AB is this top side of my triangle, so it's parallel to the midsegment that's connecting that left and right side. FE. And then this last one gives me a blank. So what we need to do is find out which side of the triangle we have not used. Well, I used the top one, AB, in that second example, and I used this left one, AC, in that first example. So this must be talking about BC. And BC is going to be parallel to the midsegment DF. Midsegments aren't just parallel, they also have a lot of congruency. So this midsegment DE, he is congruent to 2 other segments in this triangle diagram. What happens is when I take DE, remember the midsegment is half the length of that third side, or in other words, the third side is twice the length of DE. I could take DE and slide him down and see that he is the same as AF. Because F is that midpoint, which means it's splitting it half and half. And I could do the same thing and find FC is also congruent to DE. If I just slide DE down, there's FC. Now we're looking at FE. So we're going to take FE and we're going to slide him to that third side and find that AD is congruent. Remember, D is a midpoint, so that means it's equal on each side. And then also FE is congruent to DV. DF, my last midsegment. I'm going to pause for a moment and let you guys figure out which other 2 segments are congruent to DF. Take that segment and slide it across like we've been doing. Alright, so DF is going to be congruent to BE and EC. So those are those general properties of a midsegment. Let's look at what our geometry statements would look like. So this first one we need to complete. It says 2EF. Well, EF is our midsegment here. And if I have 2 of those, that's going to equal the side AB. Because remember, I can take EF and I can slide it to the left, I can slide it up towards the right, and I see that 2 EFs will make up EB. My second geometry statement there talks about segment AC. And we need to know which segment, when I double it, gives me AC. That would be the midsegment that's parallel. DE. If I double DE, that's like saying I can take it and slide it across towards the top and bottom to get all of AC. And then my final geometry statement here, we want to know which midsegment can we double to get to BC. That's going to be DF. All right, so there's all of our big ideas and the general understanding about midsegments and triangles. Let's put some algebra to this. Okay? So here's some rapid practice, okay, which means that we're not going to show a lot of work. It's just going to be we do and do and do it. So DE is a midsegment of triangle ABC. Find the value of x. So here we have, in this first one on the left, DE is a length of 7. What's the length of AB? Remember, a midsegment is half the length of AB, or that side is twice the length of the midsegment. So if DE is 7, AB is 14, because 7 times 2 is 14. The middle one isn't even talking about our midsegment. This middle example, we need to remember that midsegments connect midpoints. And midpoints mean that they're exactly in the middle. So if I'm looking at these values here, 8 is on the right, and if E is exactly on the middle, that means 8 will also be on the left. My final example, over here on the right, AC is 34, find DE. Well, remember, AC is twice the length of DE, or you could flip that and say DE is half of AC. So 34 divided by 2 is 17. So now we've done some just concrete number examples. Let's put some expressions in here. Here we're going to solve for x. So DE is 4x plus 5. So 4x plus 5. And then GJ is 3x plus 25. So GJ is the whole length, and that is 3x plus 25. So we need to ask ourselves, what is the relationship between these two green lines, or these segments with these expressions? Well, GJ, we know, is twice DE, right? The side is twice the midsegment. So now that I know this and I've written it down, I can go ahead and plug in those algebraic expressions. GJ is 3x plus 25. And then 2, DE is 4x plus 5. And now we solve. We'll start off with distributing our 2. I'm going to move my 3x over. Now move the 10 over. We're trying to get x by itself. And finally divide by 5. So in this case, x equals 3. Okay, example 2. Find the length of EF. So EF is 2x plus 7. And GH is 5x minus 1. First thing we have to recognize is what is the relationship between these two segments? Well, we know that that whole third side is twice my midsegment. So my full length side is GH is twice the midsegment EF. Now all we need to do is go ahead and plug in our algebra expressions. GH, 5x minus 1, times 2 EF. Distribute your 2. I'm going to move my x over. And I'll move the 1 over. So x equals 15. The problem, however, does not ask for x. It wants us to find the length of EF. Once you find your x value, we're going to take this and plug it into the expression for EF. So EF equals 2x plus 7. And instead of putting x, we're going to go ahead and plug in 15. 2 times 15 plus 7. 2 times 15 is 30. And then add 7. EF equals 37. All right, here's another example. Find the length of EF. And it tells me HD is 3x plus 29. And DG is 14x plus 7. So now we don't even use a midsegment. We're just using the side GH, and we're using the different pieces of it. What we need to remember are midsegments connect midpoints. And midpoints are exactly in the middle, which means both sides are equal. So if it's a midpoint like this, we can say GD equals D8, because that D is right in the middle. Go ahead, plug in your algebraic expressions. Now solve for x. Move my 3x over. Subtract 7 from each side. And then divide. So we have x equals 2. But notice it wants the length of EF. Now we have a small problem. I don't have any expression to tell me what EF is. Nothing in my problem says EF equals this. It only tells me something about DH and GD. So what is the relationship between DH or GD in relationship to EF? Well, remember when we took this segment and we slid it across? EF is going to be congruent to both of these segments. So what you can do is you're going to take your x value and plug it into either one, HD or DG. It does not matter. You will get the same answer for both. So HD equals EF, which would be 3x plus 29. So plug in 2 for x. EF equals 35. And you'll get the same thing if you use DG. If I used EF equals DG, and that's 14x plus 7, if I plug in my 2, 28 plus 7 is 35, and that's still EF. So it does not matter. You just need to pick one or the other, okay? Okay, last problem. I want you guys to try this problem here. Go ahead, set this up. We are looking here at HJ. That's 8x minus 2. And we're looking at DF. (2x plus 11). So I want you guys to go ahead, set this problem up, and solve for x and see if you guys can find the length of HE as well. Okay, press pause, set it up, solve for x. Okay, so when you set this problem up, okay, our geometry is going to say that HJ is twice that midsegment DF. And now I can go ahead and plug in my algebraic expressions. So 8x minus 2 is HJ, and then I have 2 times DF, which is 2x plus 11. Distribute this 2. And now we're solving for x. We're just going to move our 4x over. Add 2 to each side. And then divide by 4. So x would equal 6. So hopefully you were able to make it there. What you may not have recognized is how to find HE, because we do not have an expression for HE again. You need to look for a relationship. So one relationship you could have is HE equals DF. So this is one way you could do it. And you could say that DF is 2x plus 11, and plug in your 6, and find that HE equals 23. That's one method. The other thing you could have said, well, HE is half of HJ. So HE equals half of HJ. So algebraically, this would be 1/2 8x minus 2, and then go ahead and plug in your x value. So 1/2 of 8 times 6, and then minus 2. 8 times 6 is 48, minus 2, and we still have a 1/2. 48 minus 2 is 46, so 1/2 of 46 equals 23. And it does not matter which way you did this. Notice we got 23 for HE both times. All you need to do is find which relationship you can recognize. Do you see that HE equals DF, or do you see HE is half of HJ? Both of those are going to be correct. Okay. So a few things to remember. Remember that midsegments connect midpoints. So if these are midpoints, then AD is congruent to DB, and DE is going to be congruent to EC. FA is congruent to FC. All of those are midpoints. Each piece of those divided up sides are congruent. Other thing to remember that's important is that third side is twice the length of your midsegment. So 2 FEs is going to equal AB, that third side. 2 FD is going to equal BC. And 2 DE is going to equal the length of AC. And that's because when you take that length, that midsegment, you slide it right down, and you can see that 2 of my midsegments make up that third side. And that's it for this lesson.